The first thing I'd like you to do is we are going to change the title of chapter 7.1. Instead of solving things graphically, we are going to look at the general solution in 7.1. And our warm-up is a warm-up from chapter 6. So chapter 7 reviews everything that we've done from chapter 6 at the beginning and just adds a new tiny concept to it. So here's our warm-up. You can do this on page, what page are we on? On page 572. You can start on 572 and then there's space on the top of page 573. Question number 1 is a calculator question, so take out your calculator. And I'll put up the answer in a bit. All right, you can check our first one. So you would get sine theta by itself. Sine theta equals negative 2/3. Then you find your reference angle by doing sine inverse of positive 2/3. So that's the first thing you wanted to check. Did you get the right reference angle? Did your calculator tell you it's negative? Then you did the wrong process. You always have to do sine inverse of positive 2/3 to find your reference angle. And then because sine is negative, your answers should be in quadrants 3 and quadrants 4. So a couple things to notice. I didn't draw out the triangles in quadrant 3 and 4. I showed a little bit less work, which is totally fine. You're allowed to do that. This would be like the minimum amount of work you would need to show now that we've done this. Beginning, I was showing more work, and now, same thing here in B. Can you get tan by itself? Can you get your reference angle by doing tan inverse of positive 3/8? And then tan is negative in quadrants 2 and quadrants 4. So there's our two solutions. So again, it uses reference angles, angles in standard position, our cast rule, and these two were calculator ones. The next two that we're going to do are non-calculator ones. So, everybody good? Yes? Okay. And this is what's new in chapter 7, which combines actually two ideas from chapter 6 together. Can you solve between 0 and 2 pi? Which, yes, we already know how to do that. And do you know how to write coterminal angles? Yes, we already know how to write all angles coterminal with something. That's when we added the 2 pi times k, or the 360 degrees times k, where k was an integer. So we're going to introduce that today. Usually, if things are non-calculator, what happens? You solve and you get something on your unit circle. But this one was a little problematic, right? Did you get this far? And now some of us are stuck? That's not on your unit circle. How can I do this without my calculator? Well, try to draw that picture. It's never possible. This would be like 4/1. And if I tried to draw a right angle triangle, with an angle theta, and my adjacent side is 4 and my hypotenuse is 1. Can you see why this is bad? This is never possible. Your hypotenuse always has to be the biggest. So whenever cos or sine, this isn't true for tangent, but whenever sine or cosine is bigger than 1, or a negative number less than 1, it's never going to be possible. And that's why this is a non-calculator question, because you need to be able to recognize that. So what does it mean in the green box that theta belongs to all real numbers? Usually in chapter 6, you solve between 0 and 2 pi, once around the circle. Now they're saying you're not restricted. You solve every single solution you need to write down possible. So you have to go around the circle once, find those answers. Then go around the circle the second time, those answers. The third time, infinite amount of times. And find every single answer. And so what it does is it combines solving between 0 and 2 pi. So if I would get tan by itself, I get negative 1 over root 3. I hope that you quickly recognize that this is the same as negative root 3 over 3. And that is on your unit circle. It's part of your pi over 6 family. And because it's part of our pi over 6 family, we could solve for theta and say theta has to be negative in quadrant 2, in quadrant 4, 5 pi over 6, and 11 pi over 6. And these are answers first time around the circle, so that's answers between 0 and 2 pi. Now if you get answers between 0 and 2 pi like this, and I've got a picture drawn here, if we kept going, you'd have so many of them. Every single one that ends here and every single one that ends there is also a solution. So chapter 7 combines coterminal angles with solving between 0 and 2 pi. If 5 pi over 6 is one of my answers, then I can write all coterminal angles with 5 pi over 6 by adding 2 times pi times k. And for whatever reason, they like to put the k in the middle, so we'll go 2k pi. And all the coterminal angles with 11 pi over 6 would be 11 pi over 6 plus 2k pi. Of course, k has to be an integer. And this is called the general solution because it tells us every single answer that would make this work. It means that apparently if I plug in, if k is 1, then this would be 17 pi over 6. And if I plug in 17 pi over 6 for 10, I get negative root 3 over 3. Every single possible answer is now added, and this is called the general solution. Now, I drew the picture out here. This is only true with tangent, but can you see that tangent, because negatives are in 2 and 4, positives are in 1 and 3, the period of tangent is pi. So technically, I could write all coterminal of 5 pi over 6, but I could also go from 5 pi over 6 and just add pi, and I would have got to 11 pi over 6. And if I added pi, I would get to this one. So this answer is not wrong, and you can write it this way, but if it was a multiple choice question, you might also see the answer written like this. Start with one of them, and just jump by pi would get you to the next one. And jump by pi would get you to the next one. So the big answer with the 2k pi's is how we'll do it most of the time, because you have to do it that way with sine and cosine. But with tangent, sometimes you'll see it simplified even further. So I'm going to get you to turn to the top of page 574 and before we get to our example 1, a little description of what the general solution is and our steps for solving it. So if you get a question that says find the general solution, or the question tells you the domain is everything, theta belongs to all real numbers, what we're going to do is basically combine two ideas from chapter 6. Can you solve like normal from 0 to 2 pi? And then for every solution you get between 0 and 2 pi, you just have to say every single thing that's coterminal with it. So adding 2k pi, where k is an element of the integers, is our way of finding everything coterminal with that answer. And doing those two things combined will tell you the general solution for every single answer that works. So this is one of the reasons we start chapter 7 before our chapter 6 test. Because basically we're just doing two chapter 6 things together in one question. You already know how to solve between 0 and 2 pi. You already know how to write down coterminal angles in the general form. And this just combines the two of them together. So the actual question number 1 that's down below, you can put an X through it because we're going to do this question instead. So you can put an X through that one. We're going to do this question instead. We're going to solve for theta, where theta is a real number, and our question is 7 sine theta plus 1 equals 0. So what do? We want to solve for theta. We get the sine theta by itself by moving the 1 over and dividing by 7. And then take out your calculator and find your reference angle. And your reference angle is 0.143. But for your reference angle, you have to do sine inverse.
No.
Second. That line
The negative.
is 0.
Negative 0.
No, so to find your reference angle, you have to go shift, sine inverse, positive 1 divided by 7. And because sine is negative, then you would write your answers in quadrants 3 and quadrants 4. That's part 1 of the general solution. You just solve between 0 and 2 pi. Is your calculator not giving you that value? Are you in radians? Or are you in degrees? What does it say at the top? Does it say D or does it say D? So you're in degrees. So you need to hit your mode button, setup button. Shift, setup. You're in 3, or the number 4 for radians. And you'll have to switch back and forth a lot on the exam because the question will go from degrees, then the next one's in radians, and the next one's in degrees. So you have to know how to switch your calculator. And once you have your reference angle and your two answers, you just have to add 2k pi to both of them. We're we're going to do two more, a B and a C, so you can continue on the bottom of page 574 and on the top of page 575 if you run out of space. We're going to add two more questions to number 1. And this one I want you to try on your own.
I am so sorry to interrupt. Can I please have Arinda to the office at the bell?
Yeah, she'll be
Thank
down
you.
at the bell. Okay. So this one I just have the answer here. So you need to show your own work. Get your reference angle on your own. Use your calculator. It's a calculator question. Did you get 1.77 and 4.51? I guess I should technically have 3 decimal places to each of those. Plus 2k pi. If you didn't get those things, what could you have possibly done wrong? Did you get cos theta by itself correctly and get negative 1/5? Okay. Did you find your reference angle by doing cos inverse of positive 1/5? Because if you didn't do positive 1/5, you got the wrong reference angle, which should have been cos inverse of 1/5, 1.369. And then in quadrant 2, pi minus your reference angle. In quadrant 3, pi plus your reference angle. And then write all coterminal angles with those. Okay. So we'll do one more, and this one we'll also review using the quadratic formula. Another good thing from chapter 6, we had some questions that needed the quadratic formula. This one will review that. So first of all, this cannot be factored. If something cannot be factored, then on your formula sheet, you have, and it says for ax squared plus bx plus c equals 0, your quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. But we don't have an x squared, we have a tan squared. So if we're going to solve for this, instead of x equals, we would write tan theta equals. Our b value is 3, so negative 3 plus or minus b squared would be 9. Minus 4 times a is 1, and c is negative 7 over 2 times a. Simplifying this would give me negative 3 plus or minus 9 plus 28 negative 3 plus or minus the square root of 37 over 2. Also, okay, this says solve for theta. It doesn't say the general solution. It doesn't say theta belongs to the real numbers. If nothing is said, it is assumed you should find all the answers. So it is assumed if nothing is said that it's a general solution question. Now what I'm going to do from here is I'm going to split my page up and I'm going to go in 2 directions. One direction I'm going to write with the plus sign, and the other direction I'll do the other one with the minus sign. So I'll split up that plus or minus. We would have to get solutions for all of these. If I type these into my calculator, so I'm going to pull up my calculator here. Negative 3 plus the square root of 37, all divided by 2. And the exact same thing with a subtract sign. I get 1.541 and negative 4.541. So what I'm going to do, back on my page here. I just put it into my calculator. Because sometimes it's hard to see which ones are positive and which ones are negative when you're dealing with square roots. The mental math is harder to see. I put it in my calculator so I could see that the right-hand side here, tan of theta is positive. That already tells me with my cast rule, I'm going to be looking in quadrant 1 and quadrant 3. And on the left side, tan of theta is negative. My cast rule says I'm going to be looking for answers in quadrant 2 and quadrant 4. Obviously, these values are not on our pie plate, so we're going to have to find our reference angle by doing tan inverse of 1.541. So I'm going to go to my calculator, and I'm going to be very careful that I don't just type in 1.541, because that would mean I'm rounding early. A couple things I can do with my graphing calculator. I can go up and grab that value. If I grab that value, it not only has those decimal places, but all the other ones as well. So this means that I'm not rounding early, so I push enter. And I get a reference angle of 0.995. So then in quadrant 1, it would be 0.995. And in quadrant 3, I would have to do pi plus my reference angle. So go back to my calculator and go pi plus my reference angle from before. And I get 4.137. I'm going to do the same thing on the other side here. I'm going to find my reference angle. So again, to find my reference angle, I have to go to tan inverse. I want to go up and use this value, or you could even use this value. But what's the problem with using that value?
It's negative.
It's negative. So either I could go all the way back to that negative and delete it. I'm a little bit lazy, so I often just multiply the whole thing by -1 to make it positive. And my reference angle is 1.354. And I've showed you this trick before on your graphing calculator. It's really handy, but I like to take this answer and hit my store button and store it as X. It just makes my calculations a little bit quicker because I need to find my angle in quadrant 2, which is pi minus my reference angle, and now I can just do pi minus X. And I need to find my answer in quadrant 4, which will be 2 pi minus my reference angle, so I can just go 2 pi minus X. So 1.788 and 4.929. So this is chapter 6. Nothing we've done so far is anything different than chapter 6. We had to use our quadratic formula to get tan theta by itself. We had to get our reference angle and use our cast rule to find our answers. And what we have right now, here and here, these are solutions between 0 and 2 pi. That's once around your unit circle. The only thing new for general solution is that the general solution says we need to write everything coterminal with these. So I can list them. Some people like to do them in numerical order. It does not matter. I'll put them in numerical order. Take all four of our answers, and to each one, that one we add 2k pi. This one we add 2k pi. This one we add 2k pi. Draw a straight line, and define that k is part of your integers. And now we have the general solution. So we first solve between 0 and 2 pi, and then once we've found all of our answers, we write everything coterminal with each of those answers. So we combine two ideas from chapter 6, and that is the general solution idea for chapter 7. And you can circle questions 5, 6, and 9.